Everybody, namaste, welcome back to my YouTube channel. I'm here again with another video. Today we'll be looking at DFA. What is DFA? What are its basic components? And why do we actually use DFA? So DFA is basically a concept of theory of automation. It can be understood as a concept that can be applied to compilers and understand how the compilers can be designed or how it works. So it works on a finite set of data that has only single or unidirectional connections. I hope some of the basics are clear. Now let's move on to the definition. So today agenda would be a fundamental, we'll be discussing about DFA, that is a fundamental concept in computer science. We'll be unraveling the important concepts of DFA and understand how to construct them and learn how to solve problems using these powerful tools. So what is DFA? DFA is deterministic finite automata. Now that's just what the full form. What exactly is it? It is a mathematical model of computation that recognizes a specific set of strings. The specific set of strings have a unidirectional composition. That means the data can be transferred from one end to the another end. It consists of a finite set of states. Those states are nothing but can be understood as Q1, Q2, Q3 of how the transition takes place and transitions between those states governed by a set of application. DFA have numerous applications in various fields, including test processing, pattern recognition, compiler design, network protocols, and more. Their ability to efficiently recognize specific patterns make them a valuable tool in this domain. We'll also be exploring some of this in the later on slides. So defining components of DFA. Now this is a very important aspect because you need to define all the components in DFA in order to complete your question or in order to answer your question. States. A DFA has a finite set of states. As already mentioned, that represents a machine's current configuration. The DFA can be in only one state at a time. As mentioned earlier, it is a unidirectional value. That means once you have made the transition, it needs to be in that particular state until unless there's a next transition. Alphabet. The alphabet of the symbols that the DFA can read, it defines a set of possible input characters. So alphabet is nothing but the symbols. Like in our daily world, we have A, B, C, D. So alphabets here recognize as symbols that we can read. It defines a set of possible input characters. We have another thing called as transitions. What are transitions? Transitions are the rules that govern how the DFA moves from one state to another based on the input symbol. The transition defines how it moves on from one state to another. And we also define a transition function in order to understand what a transition is. Start state. Always remember, you will have three states. Start, accepting stages that are the intermediate state, and then you have the final state. Start state. The DFA begins in a designated start state, that is the initial state of the machine. Accepting state. One or more states are designated as accepting states. If the DFA ends in an accepting state after processing entire input string, the string is considered accepted, otherwise it's rejected. So you have accepting strings, then you have a start state. You also have something called as a dead state. What is a dead state? Dead state is a state when a DFA reaches when there is no further transition or that possible state is not defined. Suppose the string is of AABB. You don't have possible number of states, or perhaps the transition is not successful. So where does it lie on to? It goes on to the dead state. That means that it is end. It is the end, or perhaps the string cannot be processed. Now, what are the step-by-step rules for constructing a DFA? First one is to define the problem. That is, clearly define the set of strings you want the DFA to recognize. Suppose if the string is AABB, make sure you know what it is. And when there is a set of A based on the rules, suppose the rule is it should start with the A and end with the B. It can have AB, it can have AABB, it can have ABBA, ABBB. So these are the possible number of strings. Out of that, you can take one and define the DFA. So in order to do so, you need to be able to define the DFA. Clearly define the set of strings you want the DFA to recognize. For example, you might want to recognize all the strings that contain an even number of weights based on your question. Determine states. Identify the different state DFA needs to keep a track of the input string. Each state represents a specific condition related to the problem. Now, whenever we start, you will have an initial and a final state. At times, you will not even require the intermediate states. However, if you have them, make sure to define or determine those states well in hand as soon as you get the question. Define transitions. For each state and input symbol, specify the next state for DFA that should transition to. These transitions form the core of DFA behavior. So all of this is important for the DFA's behavior. Identify the start state. Always make sure to identify the start, accepting, and the end state. The start state should start with an arrow coming towards it. The end state should always have double circles. Identify the start state. Designate the initial state the DFA starts in. This state typically represents the beginning of the recognition process. Identify the accepting state. Determine the states that represent the acceptance of the input string. If DFA ends in an accepting state, the string is considered a valid one. Now, solving a DFA, string acceptance. Start at the initial state. Always begin the process with the designated initial state. Usually define an initial state as Q naught. Read the input symbol. Read the first symbol of the input string. This symbol will trigger a transition in the DFA. Follow the transition. Based on the current state and the input symbol, follow the corresponding transition arrow to the next state. Repeat step 2 and 3. Repeat step 2 and 3 until and unless you reach the end of the string. Check for acceptance. Once the entire input string is processed, check if the DFA has all covered all the accepting state has reached an end. If it has accepted the string, the DFA is considered to be the valid one, and the accepting states are considered to be valid one. Otherwise, the string is rejected. Then you have, so we'll look at one of the solved examples. Recognize strings with odd number of A's. The problem is consider a DFA that recognizes strings containing odd number of A's. That means the set will begin with either a single A or it can have any number of A's, odd number of A's. So if I have a single A, it is considered ABA, it's considered AAB, it's considered AAAAA, 5 times is also considered. But AB will be rejected, AAA and BB are rejected. So it should consist of odd number of A's with at least one B. The DFA will have two states, even representing an even number of A's and odd representing an odd number of A's. The initial will be even. Transition of A will switch between the states, but transition of B will remain in the current state. The odd state will be the accepting state. The second one is recognize a string with exactly two B's. So the DFA will have three start states. Start one B and two B's. The start state is the initial state. On reading B, the DFA transition to one B. Another B leads to two B's. The accepting state A transition keeps the DFA in its correct state. The start and one B states are non-accepting. Second, third example 3, recognizing string ending with AB. So first of all, you have initial state A. After reading B, after reading AB. For any other string, it will be an end. Minimizing a DFA, reducing state. Identify equivalent states. Two states are equivalent if for any input string, DFA reaches an accepting state from both states. If only and if only if it doesn't for the another. So equivalent states can be understood by this. Combine equivalent state. Replace each pair of equivalent states with a single state. Transition to the combined state will be the from the original states to the new one, resulting minimized DFA. The minimized DFA will have fewer states, which will still be recognized in the same language as the original. Let's look at the last example, that is minimizing a DFA. We'll demonstrate minimizing a DFA with the followed A by A and B. This DFA has multiple states. We'll identify equivalent states, combine them, and simplify the DFA to a smaller version that will still recognize the string. So I hope this is understood by you all. I hope this makes the topic a little clearer. If it does, make sure to like, comment, and subscribe. I'll see you guys in my next video. Thank you so much. Keep learning.